If I have something on the inside, such as a theta minus 20 degrees, it means that the entire graph is going to be rotated one direction or the other. I find it easiest not to graph this directly, but instead I'm going to graph r is equal to 5 over 3 minus 2 cosine of phi. I'm not going to graph it on the regular axis in terms of r and theta. I'm going to graph it on a slightly different axis in terms of r and phi. Now, first I'll establish my theta axis. One difference is that I don't do the full big axis. Instead, I just put out a long arm indicating where theta is equal to 0. Next, ask when phi is going to equal 0, where phi is equal to theta minus 20 degrees. So phi will equal 0 when theta is 20 degrees. So draw another line here. This is going to be phi equals 0. Note that this is 20 degrees, so you have a measure of how much it's offset. Draw a perpendicular, and now this is going to be the r phi axis. Now, believe it or not, this is the simplest way of progressing. Since you're used to having theta point off to the right, just lift your paper and turn it slightly. So now phi equals 0 is headed in that direction. It might be that you have to turn your paper quite a bit to get it there, but in this case, just that 20-degree turn will do. I have cosine on the bottom. The pattern for cosine is 1, 0, negative 1, 0. In the one direction, I have 5 over 3 minus 2. That's going to be 5 over 1, which is 5. In the 0 directions, I'm going to have 5 over 3. And in the negative 1 direction, I'm going to have 5 over 3 minus a negative 2, so 5 over 5, which is 1. I like getting these numbers first, so I have a sense of how big the scale needs to be. My biggest number is 5, so that's the one I need to fit on. So I go out 1, 2, 3, 4, 5. That will be a point. I go back 1 unit. This will be a point. I go up 5/3 of a unit. Here's 1, here's 2. 5/3 is a little bit more than 1, a little bit less than 2. It's 1 2/3. Likewise here, I will go through this point. By the way, have you noticed that this is going to be an ellipse? When you get 4 positive values, it's going to be an ellipse. If you get a negative value for any of the compass points, it's going to be a hyperbola. And if it's undefined at one of the compass points, then it's going to be a parabola cupped in that direction. Next, I do ask you to include all the key dimensions. It's worth noting that in polar form, you are guaranteed to have a focus at the pole, at the origin. Now, since one focus is 1 unit away from the left side, the other focus will be 1 unit away from the right side. I also like finding the center. These are 1, 2, 3, 4, 5, 6 units apart. half of that is 3. My center is going to be right here. In order to draw a better graph, I like to draw a line of symmetry here. It also allows me to get 2 more points. Do you see how I have a point 5/3 above and below this focus? I should also have points that are 5/3 above and below this focus. Now I have 1, 2, 3, 4, 5, 6 points to draw, and I want it to bulge widest at this line of symmetry. I draw, come around, going through all of my points, and I will have a shape that looks something like this. For key dimensions, this is A, and A is going to be 3 units. This dimension is C, and C is going to be 2 units. B is going to be the distance from the center out to the edge along this line of symmetry. Now, in order to figure out what B is, I'm going to need to go back to the fact that with an ellipse, I know that C squared is equal to A squared minus B squared. Now that means that B squared should be A squared minus C squared, and B should be then the square root of A squared minus C squared. In this case, that would make B equal to the square root of 9 minus 4. B would be the square root of 5. Check and see if that looks about right. The square root of 5 is a little bit more than 2 units, and if this is 2 units, then yes, the way that I've drawn it, B is a little bit more than 2 units. So A is 3, C is 2, B is the square root of 5. If I were to ask for the eccentricity, you would say that the eccentricity is C, that's going to be 2, divided by A, that's going to be 3. Now let's do a quick check. Remember from problem 8, the first thing we did was divide everything by this number. So that would give me a 1 here. It would give me a 2/3 here. And 2/3 is the eccentricity. So this 2/3 matches what I would expect if we had done the problem 8 material. Now, I know that this doesn't look like it's been rotated, but that's because we've drawn it on phi equals 0. When we turn it back the way it was originally, with theta equals 0 pointing in this direction, you can see that now I've got an ellipse which has been rotated by 20 degrees.